Welcome to React. Welcome to the first lecture of the Fashion Fellowship's Week 1 series. In this fellowship, we bridge the worlds of fashion and technology, equipping you with the tools to launch your own commercialized portfolio website. Today's topic, Welcome to React, marks the beginning of our journey into modern web development. Just as the fashion industry is transformed by trends and innovation, the web development world constantly evolves, and React is at the forefront of this evolution. React is a popular JavaScript library for building user interfaces, initially developed by Facebook in 2013 and now used by countless companies and developers worldwide. It empowers us to create dynamic, interactive websites in a structured way. But why does a fashion-focused program care about React? Because whether you're showcasing a design portfolio or launching an online boutique, a well-crafted web presence is crucial. Modern fashion brands leverage technology to create immersive digital experiences. Think of interactive lookbooks or personalized shopping sites. React provides the means to build such experiences efficiently. In this lecture, we will set the stage, introducing what React is and why it's so valuable to your upcoming projects. At its core, React is a tool for building user interfaces, essentially the visual part of a website that users see and interact with. Before React and similar libraries, creating interactive web pages was a tedious affair. Developers manipulated the Document Object Model, DOM, the browser's internal representation of the page, directly with vanilla JavaScript or jQuery, which could become unwieldy as a project grew. Every change, like updating the content of a div or switching out an image, had to be manually handled. This imperative approach, telling the browser step-by-step how to change the DOM, is akin to a fashion designer stitching a dress directly on a model for every alteration, time-consuming and error-prone. React introduced a declarative component-based approach that made these updates far more efficient and easier to reason about. Instead of micromanaging every DOM update, with React we declare how the UI should look for a given state of data, and React takes care of updating only what's necessary under the hood. This is like a designer creating a precise blueprint or pattern for a garment. When the measurements, data state, change, the pattern adapts, and only the needed parts of the garment are altered, not the entire outfit. A central concept in React is the component. You can think of components as the modular building blocks of a web page, very much like individual fashion pieces in a collection. Just as a fashion collection is composed of distinct items, a jacket, a pair of shoes, a dress, that can be mixed and matched, a React application is composed of components, a header, a footer, a gallery item, a contact form, etc., that are developed independently and then combined to form complex UIs. Each component encapsulates its structure, HTML markup, styling, and logic, making it self-contained. For example, you might have a photo gallery component that knows how to display a set of images, and a photo item component for each image. These components can be reused throughout your site, ensuring consistency. This reuse is similar to a signature element in a fashion line. Imagine a specific trim or fabric that appears in multiple pieces of a collection, creating a cohesive theme. React's component model encourages us to identify patterns in our UI and implement them once, then reuse and compose them rather than rewriting code. This not only speeds up development but also makes maintenance easier. Improving one component immediately updates all instances of it across the site. Now, one might ask, how exactly does React efficiently update the user interface when something changes? For instance, when a user clicks a Like button or when new portfolio images are added. The magic lies in React's virtual DOM system and its diffing algorithm. The virtual DOM is an in-memory representation, a virtual copy, of the real DOM. When your data or state changes, React will create a new virtual DOM representation of the UI for the new state. It then intelligently reconciles this with the previous virtual DOM, calculating the exact differences. Based on this diff, React updates only the necessary parts of the actual web page's DOM. This process is highly optimized. To put it in perspective with a fashion analogy, Imagine you have a mannequin displaying an outfit that represents the current state of your website. If you want to change the outfit, update the UI. The naive approach would be to strip everything off and put a completely new outfit on the mannequin, updating the whole DOM, which can be slow. Instead, React's approach is like a skilled stylist who notices only the jacket needs swapping and maybe the shoes need tying differently, and leaves the rest of the outfit intact. By minimizing the changes, only altering what truly changed, the final result is achieved more efficiently. This is why React applications often feel fast and responsive, even as they grow complex. Under the hood, the library is doing a lot of optimization on our behalf. Let's also discuss declarative versus imperative programming in this context. React allows us to write declarative UI code. When you write a React component, you essentially say, given my current data, state and props, here is what I want the UI to look like. You focus on the what, describing the desired outcome. The older imperative approach is focusing on the how, and explicitly writing instructions to manipulate the page. Declarative code can be more readable and easier to debug because it's like describing a final design rather than describing each tailoring step. In fashion, this is akin to saying, this dress should have a cinched waist and flared skirt in red satin, declarative, versus providing an exact sequence of tailoring instructions to achieve that look, imperative. With React, you describe the desired UI for each state, and React's engine figures out the steps to update the DOM to match that description. Another important aspect to understand is that React is just the view in MVC, Model View Controller architecture. It doesn't prescribe how you handle data or business logic. It focuses solely on the UI layer. This gives developers flexibility. You can integrate React with different backends, libraries, or frameworks for managing data, routing, and so on. In our case, across this week, you'll see how React fits into building a full portfolio site, but also know that in industry it's often paired with other tools, for example, a state management library or a routing library. This modularity is part of React's success. It doesn't try to do everything, but what it does, UI rendering, it does excellently. Now, because React is a JavaScript library, it means that to use React effectively, you need to be comfortable with JavaScript itself. The next lecture will be dedicated to brushing up on JavaScript fundamentals, especially features of modern JavaScript, ES6 and beyond, that are commonly used in React code. Consider this analogous to mastering the fundamental techniques of fashion design, like sewing, cutting, draping, before working on an avant-garde collection. We need our base skills sharpened. We'll cover important JavaScript concepts so you don't feel lost when we dive into React code. Before concluding this welcome lecture, let's take a moment to see how React might appear in practice at a very high level. A React application usually starts with a root component, often called app, which then too renders other components. In code, a simple component is written in a syntax called JSX, JavaScript XML, which allows us to write HTML-like tags in our JavaScript code to define what the UI should look like. For example, if you wanted a component that greets the user, you might write something conceptually like function greeting. Return. Hello, world. Don't worry about the specifics of the syntax right now. Just notice that it looks like HTML inside a JavaScript function. That is JSX in action, and we'll dedicate an entire lecture to JSX later on. What this greeting component does is simple. When rendered, it produces an element that displays Hello World. If we wanted that greeting to be dynamic, say greet a user by name, we could use data and React's reactivity to do so. The key point is that components return what should be displayed, and React ensures the actual browser reflects that. As someone coming from or interested in fashion, you might find it interesting that the ethos of design systems and software is akin to creating a cohesive fashion collection. React components can be thought of as part of a design system. Each component has a defined look and behavior, just like each garment style in a collection has a defined cut and aesthetic. When you build a portfolio site with React, you are essentially creating a digital design collection, a set of components that work harmoniously to represent your brand and content. You'll be deciding on typography, color schemes, layout components, interactive elements. These choices are parallel to picking fabrics, colors, and silhouettes in fashion. And just as consistency and attention to detail make a fashion line stand out, the same goes for a React project. React as a tool won't impose a visual style, that's up to your CSS and design choices, but it will help you enforce consistency by reusing components. Why React now, and how does it tie into launching your own platform? The web development landscape has many tools, but React has remained one of the most widely used and supported. Learning React not only enables you to build your portfolio site for this fellowship, it also gives you a skill that is highly marketable. Many modern e-commerce sites, including those in fashion retail, are built with React or React-based frameworks. For instance, companies like Instagram, Netflix, and even fashion retail sites leverage React for its speed and modularity. By understanding React, you're gaining insight into how interactive product galleries, live lookbooks, or shopping carts might be built. This can empower you to later incorporate such features into your platform. Additionally, React has a rich ecosystem. For almost any feature you can think of, there's likely a ready-made library or package that integrates with React to accomplish it. Want to add a 3D product viewer? There are React libraries for that. Need to manage complex forms for inquiries or orders? There are form management libraries. We won't overwhelm ourselves with those just yet, but it's reassuring to know that as you grow your site, React's ecosystem grows with you. One more concept worth mentioning in this overview is how React applications run. React can power what's called single-page applications (SPAS). In a traditional multi-page website, each click to a new page makes the browser load a whole new HTML page from the server. In a SPA built with React, the entire site is usually loaded once, and subsequent navigations or interactions don't require full-page reloads. Instead, React dynamically updates the content on the page. The result is often a smoother, faster user experience, akin to 3 using a desktop application. It's the difference between watching a runway show on film that cuts and fades between scenes, multi-page with obvious pauses, versus being in a live show where everything flows continuously, single-page, dynamically changing. This continuous feel is something users have come to appreciate, and React makes it achievable. However, SPAs also come with considerations, like ensuring the site is still search engine friendly and that initial load isn't too heavy. Don't worry, we'll touch on these aspects later, especially in the lecture on React and the server, where we discuss how to get the best of both worlds. By now, you might be eager to see React in action or at least get hands-on, which is great. Following this lecture, in our practical session, outside of this theoretical lecture, you would typically set up your development environment. Installing Node.js, using a tool like Create React App, or a modern alternative to bootstrap a React project, and running a Hello World on your own machine. While we won't go step by step into that setup here in the lecture text, it's something you'll be doing as homework. Think of it like preparing your workspace, similar to setting up a design studio with all the tools and materials before starting to actually craft a garment. In summary, today's lecture introduced React at a high level and explained why it's worth your time. We learned that React is a component-based, declarative JavaScript library for building UIs, making web development more modular and maintainable. We drew parallels with fashion to illustrate how components are like outfit pieces and how React's efficient updating is like a tailor making only necessary adjustments rather than redoing a whole garment. We also positioned React in the context of this course, a foundation upon which you'll build your portfolio site, and a gateway to understanding modern web experiences in the fashion domain and beyond. Looking ahead, the rest of Week 1 is structured to take you from zero to deployment. After shoring up your JavaScript knowledge in the next lecture, we'll dive deep into React's own concepts, how to write components, manage data and state, make use of modern React features like hooks, handle asynchronous operations like data fetching, and more. By the end of this series, you'll not only have built a working site, but also have a rigorous academic understanding of the underlying principles, enabling you to continue developing and scaling your platform. The tone and depth will be hyper-analytical and super academic as promised. We won't shy away from theory or technical details because understanding the why and how behind the tools will make you a better developer. Thank you for your attention in this first lecture. The world of React might seem vast, but step by step, we'll navigate it together. Remember, every expert was once a beginner. Today, you've taken that important first step by acquainting yourself with the big picture of React. In the next session, we'll ensure you have the JavaScript fundamentals solidified. Think of it as refining the fundamental skills before creating an haute couture piece. Exciting things await as we continue, so let's keep the momentum going. Lecture 2. JavaScript for React. In this lecture, we turn our focus to the language underpinning React. JavaScript. Just as a fashion designer must understand the properties of fabrics, stitches, and techniques before creating a masterpiece, a React developer must have a solid grasp of JavaScript fundamentals to craft a robust web application. Our goal today is to strengthen your command of JavaScript, particularly the modern ES6+ features and programming concepts that will be used frequently as you build your portfolio site. Consider this a crash course or refresher. Even if you have some JavaScript background, it's crucial to ensure we're all up to speed on the nuances and best practices of the language as of 2025. Let's start with the basics. Variables and data types. JavaScript, at its core, deals with values of various types: numbers, strings, text, booleans, true, false, objects, arrays, and more. In older JavaScript, pre-2015, one would declare variables using the var keyword. However, modern JavaScript primarily uses let and const, introduced in ES6, for variable declarations. These two keywords allow us to create block-scoped variables, which is a fancy way of saying the variables obey the boundaries of curly braces, like within a function or loop. Const is used for variables that we don't plan to reassign. Think of it as constant, although be careful. If the variable holds an object or array, you can still mutate the contents, but you can't reassign the variable to a completely new object that you want to initialize without a value. Using let is used for variables that will change, or let and const helps prevent subtle bugs that var could cause due to its function scoping and hoisting behavior. For example, if we're keeping track of a number of likes on a portfolio item, we might declare let likes equals 0, which we can increment later. If there's something that truly never should change, perhaps a configuration value or a reference to a fixed element, we'd use const. Embracing let and const is analogous to a designer organizing materials in clearly labeled bins rather than leaving everything scattered. It introduces clarity and reduces mistakes. JavaScript's type system is dynamic, meaning variables don't have a fixed type and can hold any type of value. This is both powerful and potentially dangerous. For instance, a variable can hold a number at one moment and a string the next. In a React app, data flow through your components often as JavaScript objects, and sometimes you may deal with converting types, like getting a number from an input field which initially comes as a string. Being mindful of types, number versus string versus object, etc., is important, even if JavaScript doesn't enforce it at compile time. In recent years, some developers adopt TypeScript, a typed superset of JavaScript, for React projects to catch type errors early, but TypeScript is beyond our scope right now. We'll stick to vanilla JavaScript and just keep an eye on our types through careful programming and testing. Moving on to functions, which are first-class citizens in JavaScript. This means functions can be treated like any other value, assigned to variables, passed as arguments to other functions, and returned from functions. This functional flexibility is heavily utilized in React. In React, components themselves are often written as functions. We call them functional components. Moreover, you'll often pass functions around as props or to event handlers. For example, a button may be given a function to call when clicked. Understanding how to define and use functions is therefore essential. There are a couple of ways to define functions in JavaScript. The traditional way is the function declaration or function expression. 5. Function. Greet name return. Hello, comma. Space name, semicolon. This defines a function greet that takes a parameter name and returns a greeting string. ES6 introduced a shorter syntax known as arrow functions, which often make code more concise and readable, especially when working with callbacks or inline functions. An equivalent arrow function for the above might be constgreet, warks name, or fias return. Hello, warkais name. Or even shorter, since this function is just one return statement. Constgreet equals name equals hello, comma space, name semicolon. Arrow functions have some semantic differences from traditional functions. One key difference is how they handle the this keyword. In JavaScript, this is a context reference that can change depending on how a function is called. In classic function definitions, this can be tricky. It might refer to a global object or an object owning the method. Arrow functions, however, do not have their own capture the this. They lexically this value of the surrounding context. In simpler terms, inside an arrow function, this refers to whatever this was in the enclosing scope. This is very convenient in React, especially back when we used class components and had to pass callbacks around. Arrow functions prevented the need to explicitly bind this in many cases. Even with modern functional components, understanding this behavior is useful if you ever integrate with libraries or older code that uses this dot. In our fashion analogy, think of this as the point of reference for a tool. In a traditional workshop, a sewing machine's pedal might control one specific machine, dependent on context, whereas an arrow function is like a universal pedal that automatically links to whichever machine, context, is around it without extra setup. Next, let's touch on objects and arrays, which are backbone data structures in JavaScript, and hence in React. An object in JavaScript is a collection of key value pairs, like a dictionary. Objects are used to represent complex data. For example, a fashion portfolio item might be an object with properties like ESEO, title, evening gown, designer, Alice, year, 2025, photos. You define object literals with curly braces. Accessing and manipulating object properties is a common task. You can use dot notation, e.g., item.designer, or bracket notation, e.g., item open bracket designer close bracket, to get or set values. In React, you'll often pass objects as props or manage them in state, so being comfortable with object operations, adding properties, copying objects, etc., is key. One modern feature that's extremely handy is object destructuring. This allows you to extract values from an object easily. For example, 6const item, title, evening gown, designer, Alice, year, 2025. Const, title, designer, item. After this, the variable title holds evening gown, and designer holds Alice. This is akin to unpacking a set of fashion tools from a kit quickly instead of picking each tool one by one. Destructuring is used frequently in React, especially to pull values from props or state to use within a component. You'll see code like const, r name, price, r this dot, props, product, in a class component or directly in function parameters, e.g., function product, name, price, bias, or, which uses destructuring to immediately extract props. Similarly, arrays are lists of values, ordered by index. For instance, a list of portfolio images might be an array map, img1.jpg, img2.jpg, img3.jpg. JavaScript arrays come with many built-in methods that align well with a functional programming style, something we will explore in depth in the next lecture. Methods like filter, reduce are incredibly powerful. Instead of writing manual loops, you can often express what you want to do with an array in a higher-level way. For example, images.map.img.equals could be used in a React components render to produce a list of photo item components for each image source. Here, map is taking each element of the images array and transforming it into a React element. Understanding how these array methods work, they take functions as arguments and apply them to each element in various ways, will not only make your code cleaner, but will also prepare you for a more declarative style of programming that React encourages. Another important modern feature is the spread operator, written as 3 dots. It has multiple uses for both objects and arrays. For arrays, can be used to expand an array's elements. For example, if you have const rr1, chasser 1, 2, 3, const ir2, chasser 4, 5, 6, then r1, r2 would result in 1, 2, 3, 4, 5, 6. In React, this is useful for combining arrays of data or props. For objects, the spread operator allows for easy copying and merging. E.g., const copy equals ares. Item UR would create a shallow copy of all properties of item into a new object copy. Or you can do year 2026 to copy an object but update, override the const new item. Shaki, item, year property in one go. This is extremely relevant for state management because a principle we'll come to is that we do not mutate state directly, but create new updated state objects. The spread operator makes that convenient. If we have a state object representing, say, a designer's profile, and we want to update just the bio, we might do something like set profile, prev profile, yain, waki, prev profile, bio, new bio, laming, which copies the previous profile and updates the bio field. This is analogous to copying a design template and just changing one aspect for a new iteration, rather than scribbling over the original design. We should also mention template literals, which are string literals enclosed in backticks embedded expressions. Instead of concatenating strings with plus, you can do let user assign Alice. Console.log, welcome, user. This would output welcome Alice. This syntactic sugar is not only convenient, but improves readability, particularly when constructing messages or complex strings. In React, you might use template literals for 7 things like dynamic class names for styling or building URLs, etc. It's a small feature, but it keeps our code clean. Another small but useful feature is the ternary operator, which is a one-liner replacement for an if-else in expressions. It looks like condition, value, if true, value, if false. In React's JSX, you cannot directly put an if statement inside the return, since it's not an expression, so you often use ternaries to conditionally render something. For example, items.length greater than 0? No items found. Inside JSX would display the list if there are items, otherwise a message. Ternary is extremely common in React code for outputting conditional content, so recognizing and using it will be important. Beyond these fundamentals, a critical aspect of JavaScript for React developers is understanding asynchronous programming. In web apps, a lot of operations are async, notably fetching data from a server. JavaScript uses a model of concurrency based on an event loop and promises. You might have heard of or used promises, objects that represent a value that may not be available yet, like the result of an API call. Modern JS added async/await syntax, which makes working with promises easier by letting us write asynchronous code that looks synchronous. For example, async function, fetch data, try const response, shines await, fetch, API, example.com data, const data, await response, .json, console.log, got data, or psalm, data. Catch, error, console, error, error, fetching. Data, error. Resolves or rejects, which is caught by definitely use fetch and catch. We'll async await when we incorporate data into our React app in a later lecture. It's vital to grasp that JavaScript does not wait for things by default. It sets them in motion, like requesting data, and moves on. But with await, we can write code that appears linear. Under the hood, the event loop will handle that asynchronously. This concept might seem abstract now, but think of it this way. You send a request for information much like sending a letter. Instead of halting all work until the reply comes, you keep doing other tasks. This is JavaScript's event loop, handling other events. When the reply arrives, the promise resolves. You handle it. Your async function continues after the await. This approach keeps applications responsive. In our fashion metaphor, imagine ordering fabric from overseas. You don't stop all work in your studio while waiting for the fabric shipment. You work on other pieces. When the shipment arrives, you then resume the task that needed that fabric. The async await pattern helps manage such situations in code gracefully. Now, another fundamental piece of JavaScript is scope and closure. Scope pertains to where variables are accessible. JavaScript has function scope and block scope, with let/const. Closures occur when an inner function remembers the variables from its outer function even after the outer function has returned. This is a powerful concept that enables patterns like function factories or maintaining state in a functional way. In React, closures appear, for example, in hooks. When you use the useState hook, the state-setting8 function you get keeps a reference to the component state even after re-renders, effectively forming a closure over the state variable. Similarly, if you define an event handler inside a component, it closes over the component's variables and props, which can be both useful and something to be mindful of to avoid stale values. Understanding closures will help you reason about why certain values in React might freeze or not update as expected if not captured correctly. Event handling in JavaScript is another topic, and while React handles events in its own way, synthetic events, which we'll cover later, you should know the basics. An event like a click or key press can trigger functions, event handlers. In JavaScript, you'd normally add an event listener to an element. In React, you'll instead pass a function to a component like dot. The main difference is that React wraps events in a synthetic event system for consistency across browsers. But at the end of the day, you're still writing a JavaScript function that will run when the user interacts. Keep in mind, by the time you are writing React code, you won't often call addEventListener manually. You rely on JSX attributes like onClick. But knowing how events propagate, bubbling up the DOM, etc., is useful when you need to handle more complex interactions. We should also briefly mention ES modules. Import-export syntax. Modern JavaScript uses the import and export keywords to organize code into modules. In React development, you will split your code into many files, each exporting certain components or functions, and you'll import them where needed. For example, if you write a component navbar in navbar.js, you might export it with function navbar, and then use it in your app by writing export default import navbar from /navbar:. The module system helps keep code organized and prevents polluting the global namespace. It's akin to how a fashion designer might keep different tools in different drawers. Each module has its own scope for variables, which avoids conflicts and makes it clearer what depends on what. Build tools and modern browsers handle these modules behind the scenes, with bundlers packaging them for the browser to use. All React codebases make heavy use of imports-exports, so understanding that import yaks something sauce from library brings in a function or component from elsewhere is important. Sometimes you'll see named exports, using curly braces in import, versus default exports, no braces, grabbing the default. And we'll use both in our project. Now, having touched on many technical facets of JavaScript, let's connect it back to how this serves us in building a React application, especially one that a fashion professional might need. When building an interactive portfolio, you might need to implement image carousels, forms for contact or feedback, filters to sort your designs by category, etc. Each of these features will lean on JavaScript heavily, to loop through items, arrays, to respond to clicks, functions, and events, to show hide sections using Boolean state variables, and to fetch data like perhaps pulling in your Instagram feed using async requests. Mastering JavaScript fundamentals means you can implement those features with confidence. Think of JavaScript as the language of interactivity on the web, the threads that weave the fabric of a web page's behavior. HTML provides a structure, the mannequin, in a sense. CSS provides style, the clothing, fabric on the mannequin. And JavaScript provides movement and responsiveness, like the choreography of the model wearing the clothes. React is built using JavaScript to orchestrate changes to the HTML structure based on user interaction or data, which is why we're dedicating time to ensure you are comfortable with JS. Without this foundation, using React would feel like trying to design a dress without knowing how to cut or sew. Finally, let's address one potential challenge. JavaScript, especially modern JavaScript, has a lot of features and gotchas, but you don't need to know every single method or quirk by heart. What's important is to cultivate a strong mental model for how the code executes. For example, understanding that JavaScript is single-threaded. It can do one thing at a time but uses the event loop to manage asynchronous tasks. Helps explain why, say, a long-running loop can freeze the UI, or why your console.log might appear before an async operation finishes. Understanding prototype inheritance, how objects can inherit properties from a prototype chain, can help in debugging or using classes, if you ever use class components or other OOP patterns. We won't dive deeply into prototypes or older features like this binding in classes since our focus will be mostly functional, but I encourage curious learners to explore those topics as well for a fuller picture. For our immediate needs in this fellowship, we'll practice these fundamentals as we go. When writing React code, you will naturally use these features. If something feels unfamiliar, refer back to this lecture or additional JavaScript references. There's also an element of style in writing JavaScript. Just like in design code, can be written in many ways to achieve the same end, but some ways are cleaner and more maintainable. For instance, using array methods and avoid mutating data directly often leads to fewer bugs than using low-level loops and modifying objects in place. We'll adhere to best practices: immutability, not changing objects, arrays directly, but making copies with modifications; clarity, using meaningful variable names and structuring code into small functions; and leveraging modern syntax, like arrow functions and template strings, for brevity and clarity. In conclusion, this lecture has revisited the essentials of JavaScript with a focus on those most pertinent to React development: block-scoped variables, let/const, data structures, objects and arrays, and their manipulation, destructuring, spread operator, functional constructs, first-class functions, arrow functions, map, filter, and asynchronous handling, promises, and async awk await. If any of these concepts still feel fuzzy, don't worry. We will be reinforcing them in the upcoming lectures through practical usage. As with learning any skill, repetition and application are key. Think of it like practicing basic sketches and seam techniques in fashion. It might seem tedious, but it pays off when you embark on designing a full collection. So too will these JavaScript basics pay off as we start building components and features in React. Up next, we delve into a specific programming paradigm that heavily influences React's design: functional programming. This will further solidify some concepts we touched on, like treating functions as values and avoiding side effects, and show you a powerful way to think about structuring your code. It's a more abstract topic, but one that will give you deeper insight into why React and many modern libraries are structured the way they are. Until then, take a breather if needed. Perhaps try writing a few simple JavaScript snippets on your own to sum up numbers or manipulate an array, just to get your hands warmed up. We'll build on this foundation very soon. Lecture 3: Functional Programming with JavaScript. As we continue our journey, we arrive at a paradigm that underlies much of React's philosophy: functional programming. In this lecture, we will explore what functional programming means in the context of JavaScript and why adopting a functional mindset can lead to cleaner, more predictable code, a trait highly valued in React development. This topic might feel a bit theoretical, but rest assured, its practical implications will surface everywhere in your React code. Think of this as learning a design philosophy in fashion, like minimalism or sustainability. It's an approach that influences how you create, not a feature or tool by itself. Similarly, functional programming is a style of writing and organizing code that emphasizes certain principles, which we'll break down and relate to our project. Let's begin by contrasting functional programming with the more traditional imperative or object-oriented styles. In imperative programming, which is how a lot of older JavaScript code was written, you focus on how to do tasks, writing step-by-step instructions and often modifying program state along the way. Object-oriented programming, OOP, centers on objects that hold state and have methods to manipulate that state, often spreading behavior across many objects that interact. Functional programming, FP, on the other hand, focuses on what to do by composing operations, and it avoids sharing state or mutating data. FP treats computation like evaluating mathematical functions. Given some input, you get an output, and if you give the same input again, you get the same output. This property is called purity. Moreover, functional code tries to avoid side effects, changes in state or observable interactions with the outside world, especially in the core logic. Why does this matter? Because code that is pure and free of side effects is easier to test and reason about. If a function doesn't depend on or alter some hidden state, you can trust it to do the same thing every time, making the system more predictable. In JavaScript, functional programming is not enforced by the language. JavaScript isn't a purely functional language, but it provides features that allow a functional style. We've already touched on some functions as first-class values and methods like map and filter that encourage treating arrays in a declarative way. Let's drill into a few key FP concepts. 1. 2. Pure functions. A pure function is one that, given the same inputs, will always produce the same output and does nothing else. No side effects like modifying a global variable or writing to a file, etc. For example, consider a function computeTaxPrice that returns price times 0.08. That's pure. It reads no external state and writes no external state. It just computes and returns. On the other hand, a function that does user balance plus equals amount, modifying a global variable, or one that calls an API or logs to the console is not pure. Those are side effects. In React, especially in component rendering and in reducer functions, when using useReducer or Redux, pure functions are a goal. A React component, ideally for a given set of props, will always render the same UI, i.e., it's like a pure function from props to React elements. This purity allows React to optimize re-renders, and it makes components easier to test. You give some props, you expect a certain output. Similarly, global state management often uses pure reducer functions to determine new state from old state and an action, without side effects. If a function has to do something like data fetching, which is a side effect, we isolate that in specific places, like inside useEffect hooks or thunks, rather than mixing it with pure logic. Immutability. Functional programming favors not changing data in place. Instead of modifying an existing object or array, you create a new one with the changes. This ties closely to pure functions. A pure function wouldn't alter an input object. It might create a new object representing the updated 11 state. In practice, immutability in JavaScript means using methods that don't mutate or making copies. For instance, concat on an array returns a new array instead of pushing into the existing one, which would mutate it. Or using the spread operator to create new objects, as we discussed. Why is immutability so important? Because if no piece of code is unexpectedly changing an object behind the scenes, you avoid a whole class of bugs. It's like in fashion, imagine if a base pattern template is immutable. You never cut it up. You always trace a copy and cut the copy for alterations. This way, your base pattern is always intact for reference and reuse. If you had just one pattern piece and kept cutting and taping it for modifications, eventually you might ruin it or not recall what the original looked like. In programming, when objects are freely mutated, it becomes hard to track who changed what and when. React's component state is often treated as immutable. You don't directly modify this dot state or a hook state variable. Instead, you call a state update function with a new value or new object. This is also how React can efficiently re-render. By comparing old and new values, especially for objects, if you mutate it in place, React wouldn't easily know something deep changed. But if you give it a new object, it can see the reference changed. 3, 4, 5. Higher order functions. This term refers to functions that operate on other functions, either by taking them as arguments or returning them. This is possible in JS because functions are just variables. Array methods like map are a great example. Map takes a function as an argument. You provide a function that says how to transform one element, and map applies it to every element. You likely have used or seen filter takes a function that returns a Boolean for each element to decide whether to keep it. Or reduce takes a function that combines an accumulator with each element to reduce the array to a single value. These patterns are very functional. Instead of writing a loop that accumulates results, you declare what you want to do with each item and the library function handles the iteration. In React, higher-order functions appear not only in array utilities, but also conceptually in things like higher-order components, HOCs, which are functions that take a component and return a new component with added functionality. HOCs were a pattern used especially before hooks to reuse component logic. For example, a with authentication HOC might wrap a component and add authentication logic. While we use hooks now more, HOCs are still a functional pattern. Another example, in functional programming, you might have a utility function that takes in some configuration and returns a new function tailored to that. This is similar to a fashion designer creating a base pattern and then making a few specialized versions of it by partially filling in details. First-class and anonymous functions. We've covered first-class nature. Anonymous just means you can create functions without naming them, like nums.map_lx_x_r2. The function x2 has no name. It's defined inline. This encourages passing around logic succinctly. In React's JSX, you'll often pass an anonymous arrow function as an event handler, e.g., setCount, count plus 1. Add. This inline function is created on the FLI, which has some performance implications, but React optimizes a lot. And you can also use hooks like useCallback to memoize functions. The ability to use inline throwaway functions means we treat functions like any other piece of data, which is very idiomatic in modern JS function composition. This is about building complex operations by combining simpler functions, almost like snapping Lego blocks together. If you have two functions, fx and gx, you might compose them to get hx equals fgx. A practical example. You might have one function that sanitizes input text and another that counts words. Compose them, and you get a function that counts words in sanitized input text. JavaScript doesn't have a built-in operator for composition, but you can do it 12 manually or use utility libraries. In React, composition is often at the component level. You compose UI by nesting components, but also in logic, you might compose smaller functions. For example, using multiple array transformations in a row. Data filter, condmap. Transform is function composition in action. The output of filter feeds into map. Now, let's tie this to React. React's API, especially with hooks and functional components, really shines when used in a functional style. In older React with classes, we often had to worry about the this context, we mutated state with this set state, which behind scenes creates a new state anyway. And we often ended up with imperative sequences in lifecycle methods. With functional components and hooks, we tend to write smaller functions that do one thing, a component rendering some UI or a hook encapsulating one kind of behavior. And we piece them together. The guidance is often to avoid side effects in the rendering process, meaning your component's function, when called, should just calculate what UI to render and not, say, directly trigger an alert or make a network request. Side effects like data fetching or subscriptions are meant to be handled in useEffect, which itself takes a function. Again, functional concept. You give useEffect a function to run as an effect. Even in useEffect, best practice is to keep the side effect logic separate from rendering logic. We define what we want to do when some value changes, and React takes care of executing it at the right time. There's also an alignment between FP and React's unidirectional data flow. Data flows down from parent to child as props, and events bubble up or trigger state changes. This one-way flow is easier to reason about than a two-way binding system because it avoids unintended side effects, like in some frameworks, changing one thing magically updates something else, which seems convenient but can lead to unpredictable interactions if not careful. React's one-way flow and emphasis on immutable props, you're not supposed to change props inside a child, reflect a functional thinking, data in, view out, pure function. And if something needs to change, a new data is emitted, state update, rather than altering the existing data structure willy-nilly. We also see functional influences in libraries that often accompany React. Consider Redux, a popular state management library, which some of you may use eventually. Redux has a central store and uses pure reducer functions to update that store. A reducer in Redux, or in the useReducer hook in React, is the epitome of functional design. It's literally a function, state, action, new state, with the constraint of being pure. You return a new state, you don't modify the old state object, you don't perform side effects in it. By enforcing that, Redux can do things like time travel debugging, because every state is calculated from previous state plus action, which is reproducible like pure functions are. It also means if you dispatch the same action in the same state, you'll get the same result. Again, predictability. Now, functional programming in JavaScript isn't without its challenges. JavaScript is multi-paradigm, and not every piece of code can or should be purely functional. There are times you need side effects. What good is a program if it never interacts with the world? The key is to control side effects. A good strategy is to push side effects to the boundaries of your system. For instance, if you need to fetch data, the act of fetching is a side effect, network IO. You might isolate that in a function or hook dedicated to data fetching. That function, once it gets the data, can produce a result which is then fed into pure UI components. Think of it like how a fashion house separates concerns. The design team creates the design, pure logic of how the outfit should look. And the production team handles the actual dyeing, cutting, sewing, side effects in the world of materials. If the production team works with well-specified designs, they won't accidentally alter the design concept, they just execute it. Similarly, in code, if we design our pure logic clearly, the parts that 13 do have to interact with the outside, APIs, DOM directly, etc., can be kept from introducing unpredictable changes to the rest of the system. In practical terms, how will you apply functional programming as you code your React project? Here are a few tangible examples. You will often write small helper functions that compute some derived data from your state, rather than mixing that computation in line with rendering. For instance, if you have an array of portfolio pieces and you want to get only those tagged evening wear, you might write a function filter, evening wear pieces, that returns the filtered list. This function can be pure, it returns a new array, doesn't modify the original. In your component, you then do const evening pieces, spos, filter evening wear, all pieces, and then render those. This separation means filter evening wear is testable on its own and has no side effects. Given the same input list, it will always return the same output list. It's also reusable. Maybe later you want to filter casual pieces, and you adjust the function or write a more generic one. When handling form input in React, say a text input where the user types their name, a common pattern is to update state on each keystroke. The function you write to handle that, handler, might look like function onChange, handle, name change, event, set name, event, target, value. This is a tiny function, but note how it doesn't do anything but take the event's current value and call a state update. It doesn't, for example, directly manipulate the DOM or attempt to validate and then and there. It's kept very minimal, almost pure, though calling setState is a controlled side action within React's realm. Then you might have another function that derives whether the input is valid, but that could be a pure function, say is valid name, returns true or false. By separating these concerns, you maintain a functional style. Each piece does one thing. One updates state, another derives some info from state. We will likely use the array methods map/reduce/filter frequently. For example, rendering a list of components from data, map, removing an item, filter out the item from array, and set state to the new array rather than splicing the old array, aggregating info, reduce. Each of these transformations can be done with a pure function. Compare this to how it might be done imperatively. You might see code outside React that does for let I 0 co I b is a plus b, which is curried, add 2, returns a function that will add 2 to any number. In usage, add 2 5 yields 7. It's a contrived example, but currying can be used to configure functions. In React, you sometimes curry by necessity. For instance, if you want to pass a parameter in an event handler, you might do onClick eosar anshiu on handle delete ID bar, then onClick eosar handle delete ID. The latter would call immediately. What we did there is essentially create an anonymous function with no args that calls handle delete with the ID. A simplistic manual partial application. We fixed the rather id argument. Understanding this helps avoid confusion like, why do we wrap in an arrow function for event handlers? It's to create a new function with a fixed parameter. To keep this connected with our fashion analogy, consider how a functional approach in design might look. Imagine you have a set of basic patterns, functions, one for a sleeve, one for a collar, one for a bodice. These are like pure functions. Given some measurements or parameters, they always produce a correct pattern piece. You can then compose them, attach the sleeve to the bodice pattern, add the collar, building a whole garment pattern from smaller pieces. Throughout, you never mutate an existing piece. You don't physically cut your base patterns, you trace new ones. If you need a variation, you tweak the copy or parameter, like length of sleeve, and produce a new piece. If something doesn't work out, you still have the original pieces unaffected. That's akin to pure, composable functions and immutable data. Also, if two designers are working in parallel, like two parts of the program, if they adhere to using their own copies and pure transformations, they won't step on each other's toes by inadvertently changing a shared resource. In a program, this translates to less debugging of who changed this array that we were both using. Now, let's wrap up by emphasizing why this matters for you as a React developer. Embracing functional programming can significantly improve the reliability and maintainability of your code. Bugs are often introduced when state changes in unexpected ways or when functions produce different outputs for the same input due to hidden dependencies. By striving for pure functions and controlled side effects, you reduce those surprises. Testing becomes easier. A pure function can be tested by just calling it with test inputs and verifying outputs, with no need to set up elaborate environments. In a later lecture when we talk about testing, this will come up. Pure logic is simpler to test than impure logic. Also, performance can benefit. While some worry that not mutating objects and creating new copies might be slower, in many cases the clarity and correctness it provides let frameworks like React make optimizations, like skipping re-renders when data hasn't changed. Modern JavaScript engines are also very efficient at allocating new objects and garbage collecting old ones. And in React, updating immutably is necessary for its diffing algorithm to correctly identify changes. So the slight overhead of creating new objects is usually outweighed by the benefits of React knowing exactly what changed and updating the DOM minimally. In summary, functional programming in JavaScript is about writing predictable, modular code by treating functions as building blocks, avoiding unexpected side effects, and manipulating data in an immutable way. We've covered key principles like pure functions, immutability, higher-order functions, and composition, and connected them to React patterns like component purity, use of array methods in JSX, and state management. By internalizing this paradigm, you'll find that many React patterns, hooks especially, feel natural and powerful. It's okay if these concepts take time to sink in. They often click gradually as you practice. Many developers have an aha moment where they realize a problem that seemed hard can be elegantly solved by combining a couple of pure functions, or by mapping an array instead of looping with a bunch of conditionals and mutations. As you progress, keep challenging yourself to think, can I structure this in a more functional way? Is there a way to express this operation without explicitly iterating or mutating state? Over time, you'll strike a good balance between functional purity and practical needs. After all, software, like fashion, is both an art and a science. While the science, functional principles, guide us to robust solutions, the art is in knowing how to apply them in the real world to create something both useful and beautiful. In the next lecture, we'll build upon both our JavaScript fundamentals and functional programming concepts as we delve into the specifics of how React works internally. We'll explore what happens under the hood when you use these functional patterns to build a UI, how React takes your components, functions, and efficiently turns them into a living, interactive web page. With your newfound understanding of functional concepts, you'll be well equipped to appreciate React's design choices. Until then, consider reviewing your code from any small practice React or JS project you've done and spot where these functional ideas appear, or could be improved. It's a great way to reinforce the concepts we discussed. Lecture 4. How React Works. Having laid the groundwork with JavaScript fundamentals and a functional programming mindset, we now turn to the mechanics of React itself. In this lecture, How React Works, we will peel back the curtain and examine what happens behind the scenes when you build a React application. Understanding React's internal processes will not only satisfy academic curiosity but also inform the way you write and optimize your code. We will cover key concepts like the virtual DOM, the rendering and reconciliation process, lifecycle, how components initialize, update, and unmount, and the newer concurrent features introduced in recent React versions. Think of this as studying the engineering of a sewing machine after learning how to design patterns. Knowing how the machine operates lets you sew more effectively, avoid breaking it, and perhaps even push its capabilities. The virtual DOM and reconciliation. One of the hallmark features of React that you'll hear about often is its virtual DOM. We briefly mentioned it earlier, but let's dive deeper. The DOM, Document Object Model, is the tree-like structure that the browser maintains to represent the UI. Directly manipulating the DOM, adding, removing elements, changing attributes, is relatively slow, especially when done frequently, because the browser has to recalc styles, layout, and repaint for each change. In the early days of dynamic web pages, developers noticed that doing many small DOM updates, like updating one text node, then another, then adding a class to an element, etc., would degrade performance. React's solution was not to modify the real DOM directly each time something changes, but instead to use a virtual DOM, often abbreviated as VDOM, which is an in-memory representation of the UI. When state changes in your React app, React doesn't immediately go and touch the browser DOM. Instead, it computes a new virtual DOM representation for the new state. It then diffs this new virtual DOM with the previous virtual DOM, the one representing the UI before the state change. By comparing the two, React figures out exactly which parts of the actual DOM need to be updated to match the new state. This diffing process is part of what we call reconciliation. The algorithm is quite efficient, leveraging heuristics such as using element keys to match elements in lists, thus avoiding re-rendering entire lists if only one item changed position, for instance. The result is that React minimizes direct DOM operations, batching them and only doing the necessary ones. An analogy: imagine you have a detailed fashion sketch, the current UI, and you want to change it into another design, new UI. The naive approach is to erase the whole sketch and draw it anew, like throwing away all DOM nodes and recreating them, which is what some simpler libraries did. React's approach is more like using tracing paper. Overlay the new design on the old, see where the lines differ, and then only erase and redraw those specific lines. For example, if only the sleeve changed shape, you erase and redraw just the sleeve, leaving the rest of the sketch intact. This saves time and preserves continuity. The virtual DOM is that tracing paper model, a way to compare changes without immediately committing them to the final canvas. It's important to note that the virtual DOM is a means to an end. The goal is optimizing UI updates. There might be scenarios where the virtual DOM overhead is non-trivial. For extremely simple updates, a direct DOM update could be as fast or faster. But for typical applications with many elements, React's reconciliation shines. It also provides a predictable model. You trigger a state change and trust React to update the UI efficiently, rather than manually writing DOM manipulation code. Component rendering and lifecycle. Let's talk about what happens from the moment you call React DOM render, open parenthesis, container, close parenthesis for a web app, or its modern equivalent in React 18+, which might use create root. React will create instances of your components and manage their lifecycle. For 17 class components, if you ever encounter older code or use them, React would instantiate the class, call lifecycle methods, like component did mount after initial render, component did update after updates, etc. In functional components with hooks, the concept of lifecycle still exists, but is expressed differently. For instance, a use effect with no dependencies plays a similar role to component did mount. It runs after the component mounts. A use effect with dependencies runs after updates when those dependencies change, and returning a cleanup function in use effect is akin to component will unmount. Understanding that under the hood, React is orchestrating these phases helps explain some rules, like why you shouldn't update state during rendering, it would interrupt the reconciliation, or why certain code runs multiple times in development. React's strict mode intentionally invokes some functions twice to help detect side effect issues. The render phase is where React calls your components, render method or function component body, to figure out what UI to draw in the virtual DOM. This should be a pure calculation with respect to props and state, which is why we emphasize not having side effects in rendering. Then the commit phase is where it takes the diff and actually applies it to the browser DOM. Between these phases, React might batch multiple updates for efficiency. React in recent versions will by default batch state updates even across event handlers, meaning if you set state multiple times in quick succession, it may group them into a single render to avoid redundant work. One-way data flow and state updates. React's data flow model is central to how it works. Parents pass data to children via props. Children cannot directly modify the props they receive. If something needs to change, a child calls a function, prop or context, given from the parent, which triggers an update in the parent state, which then flows new props down. This unidirectional flow makes the app's state changes more predictable, since you can generally follow the path of data through the tree. It's like a hierarchy in a fashion house. Decisions, props, state, flow downward from higher-level components, like creative directors to designers to tailors, and results or events bubble up by reporting back. Child calls a parent callback to say, the user clicked this, or this form was submitted. There's no scenario where a lower-level tailor unilaterally changes the collection's theme. They would inform the designer, who informs the director, who then decides on a new theme and informs everyone. In React terms, an event triggers a state change at some component, which causes re-render and propagates new props. Keys and list. Reconciliation. A practical insight into how React reconciles lists. When rendering an array of items, say, mapping a list of portfolio pieces to components, React strongly encourages providing a key prop on each item. The key helps React identify which item is which between renders. If an item is added, moved, or removed, keys let React minimize reordering. For instance, if you have a list, A, B, C, and it becomes AC, without keys, React might naively re-render both A and C fresh. With keys, like unique IDs per item, React knows A is still A, so it stays, maybe just updates if needed. And C corresponds to what was originally B's position but has key of C, so it realizes B was removed and C moved up. React then only unmounts B's component and updates A and C as needed. Without proper keys, React falls back to using index as key, which can cause unintended behavior. Like if you prepend an item at the start Every item shifts index and React might reuse components incorrectly, leading to odd bugs like input fields losing focus or retaining wrong values. So keys are a way to give hints to the reconciliation algorithm to maintain stability of components. React Fiber and Concurrency. React underwent a significant internal rewrite with the introduction of the fiber architecture around React 16, 2017, enabling what we now know as concurrent rendering. Prior to Fiber, React's rendering process was synchronous. Once it started rendering a component tree update, it 18 wouldn't yield until done, which could block the main thread if the tree was large or complex. Fiber made the rendering process incremental and interruptible. Conceptually, Fiber breaks the render work into units that can be paused and resumed. This allows React to be more responsive to user interactions or other high-priority events by pausing less urgent rendering work. In React 18, the library introduced a feature called concurrent mode, or rather, concurrent rendering capabilities, since you enable it by using the new Create Root API. With concurrency, React can start rendering updates in the background without blocking the browser. And if something urgent like a user typing or clicking happens, React can abandon or defer the background work to handle the urgent update first. This leads to smoother user experiences, especially in apps doing heavy computations or rendering many elements. From a developer perspective, one of the APIs that came with this is Use Transition, which allows you to mark state updates as transition, low priority. So React knows those can be interrupted if needed. For example, switching pages in an app might be a transition. You mark the state update that triggers the new page content to load as a transition, allowing a spinner to show immediately while the content loads without freezing the UI. Another concept is suspense, which we'll have a whole lecture on. Suspense ties into concurrency by allowing components to wait for some resource, like data or code, to be ready, and letting React know to show a fallback, like a loading indicator, in the meantime. Under the hood, Suspense works with the Fiber scheduler to pause rendering of a subtree until it's ready and continue rendering other parts. Lifecycle methods. Class versus hooks. Even though functional components are now the norm, it's useful to know the class lifecycle, if only to better appreciate how hooks line up with them. Component didMount called once after initial render. In hooks, an effect with empty dependency array useEffect can simulate this. Component didUpdate, called after every update except initial. In hooks, an effect that depends on specific values runs after those values update. Should component update. A method to allow skipping re-render if components props soccer state haven't meaningfully changed. With functional components, we achieve similar optimizations using React Memo for pure functional components, or use memo/use callback to avoid unnecessary recalculations or recreations. Component will unmount, called right before a component is removed from DOM. In hooks, return a cleanup function from a useEffect to handle unmount cleanup, like canceling timers or unsubscribing from services. React schedules. These method calls or hook calls according to its phases. For instance, with hooks, all use layout effect hooks, which are like a version of useEffect that fires earlier, after DOM mutations but before painting, run in the commit phase synchronously, whereas normal useEffect runs after the painting, asynchronously. This is detail level, but you might encounter it when you need to measure DOM layout. Use layout effect for that, versus just performing async actions, useEffect. Synthetic events. When you attach an event listener in JSX, e.g. onClick equals handleClick, you're not directly attaching to the DOM element like a normal add event listener. React uses a mechanism called synthetic events. It basically sets up a single event listener for each event type on the root, and when an event happens, it maps it to your React event handlers. The synthetic event is a wrapper that normalizes events across browsers, so you don't have to worry about inconsistencies, say, between IE and Chrome historically. For you as a developer, it mostly means React events behave consistently. One thing to note, synthetic events are pooled for performance. They reuse event objects, which means if you access a synthetic event asynchronously, like inside a set timeout, it might have been cleared. To handle that, U19 can call event persist or better, extract the needed values from the event before the async call. This pooling detail is a quirk of how React works under the hood to avoid allocating tons of objects for events during rapid interactions. State updates and batching. React by default batches. Multiple state updates that happen during a React event handler. Batching means it will group them and do a single re-render at the end. For example, if inside a click handler you call setState twice with different values, React will not re-render the component twice. It marks the state changes and then re-renders once. This was historically only in event handlers, but with React 18, batching happens for all updates by default, including timeouts, fetch callbacks, etc. when using the new root API. If you do need an update to be processed immediately, rarely, there's a way, like flush sync. But generally, you rely on batching to be efficient. This is an optimization to know about because sometimes new developers get confused. I set state and then immediately console log the state value, and it's still the old value. That's expected because set state is asynchronous and batched. You won't see the effect until after the render. The mental model to adopt is, when you call setState, you're scheduling a state change. React will process it soon, usually after the function or event is done. So, do not rely on the state having updated until the next render. If you need to use the updated value to compute the next state, use the functional setState form, passing a function to setState, which we'll cover in the state management lecture. Memory and performance considerations. Understanding how React works can help you write performant apps. For instance, knowing that re-rendering a component means executing the component function again and reconciling its subtree implies that heavy computations should be avoided on each render, if possible, or memoized. That's why we have hooks like useMemo to memoize expensive calculations so they run only when inputs change, or use callback to preserve function identities and avoid retriggering child renders unnecessarily. Also, when building large lists, techniques like windowing, only rendering what's visible, become important. React will still do the diffing for a large list even if only a few items changed, meaning it will compare every item's virtual DOM representation. For huge lists, it might be better to only have in the DOM what you need, using libraries like React Window or similar. React and rendering modes, strict mode, etc. React's strict mode, which is activated by wrapping your app in development, is not a different way React works per se, but it has some behaviors to help you catch issues. As mentioned, it intentionally invokes components twice, only in development, for initial render to help catch side effects in rendering logic. It also gives warnings for deprecated practices. It's helpful to know because if you see effects running twice or logs appearing twice, it might just be strict mode in dev. In production, those would happen once. We keep strict mode on in dev to ensure we write resilient code. JSX compilation. While not exactly runtime how React works, but a build time aspect, let's quickly mention it. JSX is transformed by a compiler, Babel typically, into calls to React.createElement in React 17 and earlier, or to JSX function in the new JSX transform, React 17 Plus with new Babel plugin. What that means is hello becomes a React.createElement myComponent, prop : value, hello call in the generated code. This function call creates a lightweight JavaScript object that represents the element, with type, props, children. Those objects form the virtual DOM tree. React then goes through these objects, and if the type is a class or function, like myComponent, it will render that component, call it, or instantiate it. If the type is a string like div, it knows it's a host DOM element, and ultimately that becomes a real div in the DOM at commit time. The reason to mention this is to demystify. There is no magic in JSX. It's just a nicer syntax. And 20 understanding that the virtual DOM nodes are plain objects helps to appreciate performance. They are relatively cheap to create, but there is still some overhead. Also, each React element has a special $sign. $sign type of property to tag it as a React element and other internal properties, but as a developer, you rarely see those, except perhaps in debugging, or if you print something. Error. Handling. How does React handle errors during rendering? If an error, exception, is thrown in a component during render, by default it will unmount the whole component tree, basically crash the app's UI, unless you catch it. That's why React introduced error boundaries, available only as class components at the moment. Typically, you make a class that extends react.component and implements component didCatch. An error boundary catches errors in its child component tree during render or lifecycle methods and can display a fallback UI instead of crashing the whole app. Internally, React will catch the error, find the nearest error boundary up the tree, and use that. If none is found, it logs the error and unmounts everything. In development, you see the red screen error overlay. Understanding this mechanism is key for building resilient apps, especially as you add things like external data or user-generated content that might cause errors. While hooks don't have an error boundary equivalent yet, one might come in the future. For now, we still occasionally write error boundary classes or use a small library to handle it. React's rendering in React Native versus Web. Although our focus is web, it's academically interesting that React itself is platform agnostic. The core reconciler doesn't assume the DOM. That's why React Native can exist, where the DOM is native mobile UI components. The reconciliation, diffing, etc. all happen in React core, and then the commit phase delegates to the platform-specific renderer, React DOM for web, React Native's renderer for mobile. This modular design is how React can also render to other targets like VR, React VR, or even text-based terminals, etc. It shows that what we learn about how React works broadly applies, and only the final step of how to apply updates changes with platform. For web, it's DOM operations. For native, it's calling native UIAPIS. Now, let's consider some practical developer guidance gleaned from knowing how React works. Don't mutate state directly, because if you do, React may not detect changes properly. Always use state setters or other provided APIs. Don't manipulate the DOM by yourself, like document.getElementById and manual changes, while React is managing that part of the DOM. It might confuse React's virtual DOM accounting. If you must integrate with a third party that needs to do DOM stuff, isolate it, like useref to get a DOM element and let third-party work inside a small area. Use keys when rendering lists to help React's diffing. Be mindful of creating tons of new objects or functions every render. Not that you must avoid it at all costs. You often can't, and React is optimized for typical usage. But if you have performance issues, tools like React Memo or Use Memo can help. Understand that reading props, char state, and returning JSX should ideally be pure. If you find yourself doing something like triggering an animation or logging or fetching during render, that's not the right place. Move that to useEffect or event handlers. This keeps the render phase pure and free of side effects, which is exactly what allows React to do things like render on the server or rerun renders for debugging without adverse effects. To use our fashion world analogy for React's inner workings, think of React as a master tailor's workshop with a very organized process. The virtual DOM is like a set of clothing patterns that represent current outfits. When a change is needed, say a model's measurements update, instead of blindly cutting new fabric for a whole outfit, the tailor compares the new measurements to the old pattern, diffs the patterns, to see what panels need alteration. Only those pieces are recut or adjusted. That's reconciliation. The tailor works on these pattern adjustments behind the scenes. Off the runway, concurrent mode allows this to 21 happen without halting the show. When ready, the changes are quickly applied to the garment that the model is wearing, the actual DOM update. During a convenient break in the show, batching, and commit phase. Throughout the show, there's a strict order and method. Outfits, components, come on stage in a certain order. Mounting, may do a turn. Update, if something is added like an accessory, and eventually leave, unmount. If a wardrobe malfunction or unexpected event occurs, an error in rendering, the stage manager, error boundary, steps in to handle it gracefully without stopping the entire show if possible. The coordinator, react, orchestrates all of this such that the audience, the user, sees a seamless performance. By understanding the coordinator's role and methods, you as the designer-developer can better prepare your outfits taught components and cues, code, to work in harmony with the show. Ultimately, knowing how React works internally gives you deeper insight into why certain best practices exist and how to leverage React's strengths while avoiding pitfalls. This has been a deep conceptual and technical dive. It's normal if it feels like a lot to absorb. You don't have to memorize the reconciliation algorithm or the fiber internals. Rather, try to internalize the core ideas. Virtual DOM diffing, one-way data flow, lifecycle management, and concurrency capabilities. With these in mind, you'll write code that aligns with React's engine, which usually results in better performance and fewer bugs. In the next lecture, we will get back to writing code as we discuss JSX, the syntax extension that React uses to define UI structures. JSX is where this theory meets practice. When you write child, now you'll have the context for what happens to that code, turns into virtual DOM objects, and so on. So, onward to JSX and how we use it to build our components output in a clear and expressive way. Lecture 5. React with JSX. In this lecture, we focus on JSX, which stands for JavaScript XML. JSX is the syntax that allows us to write HTML-like code within JavaScript, and it is one of React's most distinctive features. For many newcomers, writing markup in a JavaScript file can seem strange at first, but JSX is a powerful abstraction that makes building UIs more intuitive and closely ties rendering logic with the visual outcome. Today, we'll explore what JSX is, how it works under the hood, best practices in using JSX, and some important differences between JSX and plain HTML. By the end, you'll see JSX as an elegant tool in your React toolkit, rather than a weird trick. What is JSX and why use it? JSX looks like HTML, but it isn't exactly HTML. It is a syntax extension for JavaScript that allows you to describe the UI in a declarative way. Instead of calling React createElement for every element, which you could do, but it becomes verbose, you write JSX 22 tags and let a compiler, like Babel, transform them into the appropriate JavaScript calls. For example, writing const element equals hello world is transformed into something like const element, React, create element, h1, class name, title, hello world. This React create element call produces a plain JavaScript object, the virtual DOM element. So under the hood, JSX is not magic. It's a syntactic convenience. But why is it beneficial? Because it allows developers to write the structure of the UI in a form very similar to HTML, which is natural for defining the layout of content, while still being able to intermix dynamic data and JavaScript expressions. It keeps concerns together. Instead of separating markup and logic into different files, like older paradigms with templating engines and separate JS, with JSX you define a component's structure and its behavior in one place, in one continuous flow. This cohesion often makes code easier to understand because you can see the UI and the associated code side by side. For a fashion analogy, think of JSX as a sketch in a design notebook that not only shows the visual design, like an illustration of a garment, but also has annotations inline about the materials and techniques, the logic. It's like combining the blueprint and the assembly instructions in one integrated document. That can be easier to follow than flipping between a purely visual sketch and a separate list of instructions. JSX syntax basics. In JSX, you can write any valid HTML-like tags. You can also embed JavaScript expressions inside curly braces within JSX. For example, function greeting, props, return.
Hello, props.name.
Here, props.name is a JavaScript expression inside the JSX. When this runs, it will be replaced with the actual value of props.name. If props.name is Alice, the output becomes, this is immensely powerful. It means your UI can dynamically reflect your data. Hello, Alice. A few important rules and differences when writing JSX. Every JSX element must be closed. For example, is invalid in JSX. You must self-close it like, because JSX is XML-like, which is strict about closing tags. Similarly, if you have a solitary tag, like
Right.
JSX must have one parent element. If you return multiple siblings at the top level from a component, you need to wrap them in a single parent element or a special fragment. For instance, a component can't return two S side by side without wrapping. If you don't want an extra wrapper in the DOM, you can use React fragment, or shorthand less than greater than, which doesn't render an actual DOM node but satisfies JSX's requirement of a single parent. This is like ensuring a design sketch is 23 contained on one canvas. You can't have a disjointed floating element without some container. JSX attributes versus HTML attributes. There are slight naming differences. For instance, class in HTML becomes class name in JSX, because class is a reserved word in JavaScript. Similarly, like on A becomes for in HTML, HTML4 in JSX, for the same reason. Most other attributes are the same, e.g., style, ID, etc. But when in doubt, check React documentation. Another example, in SVG or other cases, some attributes like viewbox remain camel case, viewbox, even though in HTML they might not be. But React generally uses camel case for all attribute names. One more. Instead of using inline event handlers like onClick in HTML, in JSX, you use onClick, camel case, and you assign it a function, not a string. JavaScript expressions, not statements. Inside JSX curly braces, you can put any expression which produces a value, but you cannot put statements which perform an action but don't produce a value directly. For example, you can't put an if statement directly inside JSX, but you can use a ternary operator or logical and. For instance, is logged in? Will include either or based on the condition. If you have a block of logic to determine what to show, often you do that above the return and then use the result in JSX. This is by design. JSX is meant to be used like an expression itself. JavaScript class name. We touched on class versus class name. Always use class name for CSS classes in JSX. It may feel odd at first, but you get used to it. The reason again, class is a keyword in JS for declaring classes, so class name is how the JSX transpiler distinguishes it. The style prop. In HTML, you might write black semicolon. In JSX, style equals color, red, semicolon. Background colon style takes an object, not a string. For example, text. Notice we used background color, camel case, because CSS property names become camel case keys in the style object. Also, we doubled the curly braces. One to denote JavaScript expression, and one for the object literal. Many prefer using CSS classes instead of inline styles for maintainability, but style prop is there when needed. Comments in JSX. If you want to put a comment within JSX, you have to use the curly brackets and inside them start a JS comment, r3y, or. For example, Heiss. This is a comment in JSX, on is yours one. You can't use double slash directly in JSX because it's not valid inside the XML context. Conditional rendering and lists. Because JSX is just JavaScript, you can use common techniques for conditionally showing something or rendering lists of items. For conditions, as mentioned, you can use ternaries, or condition, or logical, and, condition, and, which will render A only if condition is true, since if condition is false, it short-circuits and returns false, which React will just ignore and render nothing for false null. For lists, you might do something like items.map.item.equals. Embedding .map directly in JSX like that is common and a very clean way to generate repeated elements. Just ensure you include a key prop as we discussed in the previous lecture for each item to help React's list diffing. JSX is not a string or HTML at runtime. This is a crucial point. When you write JSX in your source code, by the time your app is running in the browser, there is no JSX present. It's been turned into JavaScript objects and function calls. This means you cannot treat JSX like a string of HTML. For instance, you can't do some jQuery-like string manipulation on your JSX before it renders. You handle changes via state props, not by treating UI as string text. This also means things like XSS, cross-site scripting, are largely mitigated. By default, React will escape any values embedded in JSX. For example, if prop's name was Yusolsun, React doesn't interpret that as HTML. It will render it as literal text, with the angle brackets escaped to etc., preventing injection. React will only render HTML if you explicitly tell it to using dangerously set inner HTML, which is a special API to knowingly inject raw HTML. So, as long as you avoid that, you can trust that user data you insert into JSX won't execute scripts. 24 JSX can represent user-defined components. In addition to built-in HTML tags, we can use our own components in JSX. The rule is, if a tag starts with a lowercase letter, React treats it as a DOM tag, like div, span, h1map, to real DOM elements. If it starts with an uppercase letter, React will look for a JavaScript variable with that name in scope and treat it as a component. For example, will be treated as a component, assuming you have import welcome from ./welcome or defined a function/class welcome. This convention is why components in React must be capitalized. If you accidentally name a component in lowercase and try to use it, it won't work as expected because JSX will think it's a DOM tag. So, always start component names with uppercase. Fragments. I briefly mentioned fragments as a way to return multiple elements. The shorthand is an empty tag pair that compiles to react.createElementReact fragment null. Fragments are useful to avoid extraneous divs just for wrapping. For instance, if a component needs to return two sibling elements, you can wrap them in a fragment instead of a div, thereby not adding an unnecessary node to the DOM for academic JSX and JAVASCRIPT under the hood. Let's consider what the BABEL compiler does with JSX in a bit more detail interest. Historically, Babel would transform into react.createElement.component.props.children. As of React 17+, there's a new JSX transform which uses functions like JSX and JSXS from the React/JSX runtime. The detail isn't too important, but what it means is you might not see React needing to be in scope anymore if you use the new transform. Previously, you had to import React from React for JSX to work because it needed react.createElement. The new transform does it differently, and you often don't need to explicitly import React just for JSX. But some setups still require it, so don't be confused if you see imports of React, even if not directly referenced. Best practices and readability. JSX encourages you to write markup-like code in JS, but it's also easy to make it messy if not careful. Some best practices. Indentation and formatting. Keep JSX well indented, just like HTML. It greatly aids readability. Most code editors can format JSX for you. Prettier is a popular formatter. Keep JSX expressions simple when possible. If your JSX inside the return starts getting too large or complex, consider breaking parts into subcomponents. Like if you have a giant chunk of JSX for a modal window within a component, maybe make a component. This is similar to not writing a single giant function for everything, but rather modularizing. If you need to do complex calculations or logic to derive what to render, do it in the JS part, then plug the result into JSX. For example, rather than writing items.length, items.map, or use inline, you might do const content, yammern items.length, items.map. Above and then just put content in JSX. This can sometimes make the JSX cleaner. Use parentheses around multi-line JSX returns. It's common to write return period. Lots of lines. To avoid any issues with automatic semicolon insertion or to visually differentiate the return value. Self-closing tags. Always self-close tags that have no children, like comma, logically, etc., as required. Comments. Use them sparingly in JSX. If you find the need to comment a lot of sections, maybe the component is doing too much or you could break it down. Avoid deeply nested ternaries in JSX, as they get hard to read. If you have multiple conditions, it might be better to compute something with if-else in JS land, and then render accordingly. For styling, you often combine JSX with CSS by importing styles or using CSS frameworks. There is also CSS in JS approach where you style via JS objects or libraries, but regardless, maintain consistency in how you apply styles to your JSX. JSX gotchas. A few things that occasionally surprise people. You cannot use a loop like for or while directly in JSX, but you use array methods or create an array of elements to render multiple items. The end in 25 trick, e.g., condition, and your lines will not render anything if condition is false. But note, if condition is something like 0, which is falsy, it will display 0 if you use it directly, because 0 will get rendered as text 0. Usually, you use and with a Boolean condition. If condition might produce 0 or an empty string legitimately, then using and can lead to those showing up. In those cases, a ternary that returns null might be clearer. The difference between pause and calling a function. If you mistakenly put a function call inside JSX without calling it, e.g., instead of, you invoke the function immediately rather than passing it as an event handler. This is a common mistake. You want to pass a reference or an arrow function to onClick, not call it onRender. Keep an eye out for those parentheses. Spread operator in JSX. You can spread props with open curly brackets, obj close curly brackets. For example, if you have age, 25, you can do const props, or she's name, Alice, which is equivalent to. This is convenient for passing many props or forwarding props in a wrapper component. But be careful not to overspread, like passing unrelated props to DOM elements, which would show up as unknown attributes in the HTML. JSX doesn't support certain HTML elements in older versions of React due to namespace issues, like inside normal JSX might need special handling to maintain the SVG namespace. In modern React, it generally handles it if you nest properly, but just something to know. If you put SVG or MathML inside JSX, ensure it's properly nested so React knows to create those elements correctly. JSX and TypeScript touch prop types. While not our main focus, it's good to mention that JSX works with type systems. If you use TypeScript, you'd typically have your files as .tsx, which stands for TypeScript plus JSX, instead of .jsx.tsx, allows type annotations for props and so forth, making your components strongly typed. If not using TypeScript, at least using prop types, a React utility to type check props at runtime, or JSDoc can help. This doesn't change how JSX is written much, but with TypeScript, your editor can catch if you pass the wrong type of value in JSX to a component. That's beyond the core, but academically, it's an example of how JSX is flexible to integrate with tooling for large apps. The synergy of JSX and the virtual DOM. Because JSX is just data after compilation, it works seamlessly with React's virtual DOM diffing. Each JSX element or component becomes an object that React can compare. If you manually manipulated the DOM, you'd lose that diffing advantage. JSX encourages you to think in terms of what the UI should be given the current state, not in terms of manually creating or updating DOM nodes. This declarative approach is a big shift from older jQuery-style coding. For example, in jQuery, you might write, find the list, append a new item element with this text. In React/JSX, you'd update an array in state, and then the JSX re-renders and includes the new item automatically via mapping. The JSX itself might not imperatively say, append, it just says, here's the list of items to display. This fits into the bigger picture of React doing the heavy lifting of updating the DOM based on what your JSX declares. Analogy with fashion. If HTML is like a static dress template, then JSX is like a dynamic dress pattern that changes based on inputs. It's as if you had a pattern cut from a smart fabric that shifts shape when you adjust a dial, the data state. The JSX is defined in a way that it can stretch or shrink as needed, like embedding expressions or conditional pieces. Instead of tailoring each outfit from scratch, imperative DOM manipulation, you have a template that adjusts to measurements easily. You still have full control over style and structure, but you're letting the system handle the repetitive cutting and stitching as measurements change. 26. Finally, I want to emphasize, JSX is optional to use with React. In theory, you could write without it, but practically almost everyone uses it because it improves developer experience. If one were not to use JSX, you'd call React create element directly or use a different templating solution, which is usually more cumbersome. Embracing JSX typically means embracing the React way of building UIs. At first, mixing markup with logic may feel counter to separation of concerns. But React argues that separation of concerns is not about file types, HTML versus JS versus CSS, but about logical units. A component is a logical concern. It includes everything, structure, style, behavior, for that piece of UI. JSX allows the structure to live with the behavior. Over time, most find this actually leads to better separation in a larger sense because components are more self-contained. With a solid understanding of JSX, you are now well equipped to write React components that are clear and expressive. In the next lecture, we will delve into state management within React, how components maintain and update internal data over time, and how that interacts with our JSX rendering. State is what brings our interfaces to life, where things change and respond to user input, and it works hand in hand with JSX. When state updates, React re-renders the JSX. You can already imagine that with what we covered, but we'll explore the patterns and pitfalls of state next. Keep practicing writing JSX in small components. Perhaps try converting a simple static HTML snippet into a React component using JSX to get a feel for it. It's a skill that becomes second nature with a bit of use. Lecture 6. React State Management. In this lecture, we explore one of the core concepts of interactive applications: state. In React, state refers to data that changes over time due to user interactions or other factors, and influences what is rendered. State management is crucial because it is how your application remembers things and updates the UI accordingly. A static page might not need state, but any sort of dynamic app, like our portfolio website where we might have image carousels like counts, form inputs, toggles, filters, etc., will rely on state to keep track of what's going on. Today, we will cover what state is in React, how to use it effectively, with the useState hook in modern functional components, and touching on how it was with classes historically. The difference between state and props, patterns for updating state immutably, lifting state up to share between components, and an introduction to contexts and more advanced state management scenarios. What is state? At the simplest level, state is a JavaScript object, or primitive, or any value, that represents some information about the component that may change. Each component can maintain its own state. For example, a gallery component might have state for the currently selected image index. A component might have state for whether it's liked, and a like button contact form might have state for the values of each input field. When a component's state changes, React will by default re-render that component and its children to reflect those changes in the UI. This is how React creates interactivity. You update state, and the UI automatically updates according to the new state, based on your render logic. JSX. 27 State versus props. It's important to distinguish these two. Props are inputs to a component, passed in from a parent. They are read-only as far as the child is concerned. A component cannot modify its props. If it needs to, that change has to happen in the parent and flow in as new props. State, on the other hand, is data that is managed within the component, though it can be passed down as props to children. A component controls its own state, meaning it can change it by calling the state update function, like setState or the updater from useState. Props are analogous to function parameters, whereas state is like local variables within a function, but that persist across invocations. In a fashion analogy, props might be like materials or measurements given to a tailor. They come from outside, while state is like the tailor's own notes and adjustments that are kept internally during the process. Using state in functional components, use state hook. In modern React, functional components use the use state hook to add state. For example, import, use state from React, function counter, const count set count, use state 0. Here we declare a state variable count with an initial value of renders. Use state returns a pair, the current state value, and a function to update it, case. We can then use count in our JSX and update it via function. Counter, const, count, set count. Use state 0. 0. React will preserve this state between set count in this set count. For instance, return dot. You clicked shash count times. Set count, count plus 1. Click me. Every time the button is clicked, we call set count, count plus 1. This tells React to schedule a state update. React will then rerun the counter component, essentially call it again, with the new count value, incremented by 1. The displayed paragraph updates accordingly. This demonstrates a key idea. State updates trigger re-renders. That's how the UI stays in sync with the state. You don't manually manipulate the DOM to update that number. You just change the state and React does the rest. A detail to remember, state updates in React are asynchronous and may be batched. When you call setCount, the state doesn't change immediately within that function call. React queues the update and will process it soon, often at the end of the event handler. If you call multiple setState or setCount in 28 a row, they might be combined in one render. This is why if you try to log count immediately after calling setCount, count plus 1, you'll still see the old value in that tick. The new value is visible on the next render. Immutability and state updates. Earlier, in the functional programming lecture, we discussed immutability. React requires that state is not mutated directly, but instead replaced with a new value, especially for objects or arrays. With useState, if your state is an object or array and you want to update it, you must create a new version of it. For example, say your state is an array of portfolio items and you want to add a new item. You shouldn't do stateArray.push new item because that mutates the existing array. Instead, do setItems, items, new item, which creates a new array that includes all old items plus the new one. This way, React sees that the state changed because the reference is different, and the old state remains unmodified, which can help with debugging, and potential future features like time travel debugging. Similarly, for removing an item, setItems, items.filter, item marks, item ID is not equal to ID to remove, creates a new array without the specific item. For objects, you might use the spread operator. setUser, prevUser, prevUser, name, Bob, to create a new object with one field changed. Why not mutate? If you directly mutate state in React, for instance in a class component, doing this .state, some field equals new value. React will not know that state has changed because you didn't use its provided setter, and thus it won't re-render at that time. Even if you call setState later, you might have lost track of changes or overwritten something. It can also lead to inconsistencies because multiple parts of state might depend on each other. So the golden rule: never modify state directly. Always use the state updater function and treat state as read-only within your render function. Functional updates. Sometimes when updating state, you need the current state value to compute the new state. If you call setCount, count plus 1, it works in an event handler because the count you're using is the one from the current closure, the current render. But if multiple updates happen quickly, or if you're updating inside something not tied to the latest render, you might use the functional form of the updater. setCount, prevCount, naciones, prevCount plus 1. This passes a function to setState, where prevCount is the value of state at that moment, and you return the new value. This ensures you're always updating from the true current state, accounting for any prior queued updates. It's like saying, whatever the previous count is now, increment it by 1. This pattern is especially useful when state updates could happen concurrently or from different events that might overlap. Multiple state variables versus one state object. In class components, state was a single object, and you'd call this setState with an object to merge into state. In functional components with useState, you can have multiple state variables by calling useState multiple times. For instance, a form component might have const first name set first name, useState const last name set last name, useState const email set email, useState. This is often clearer than one state object, first name, last name, email, that you then update with an object. But both approaches are valid. With a single object state, you have to remember to spread the previous state when updating, e.g., setForm, prevForm, Orsfees, mine, prevForm, 29 first, name, Alice, 1. With multiple state hooks, React manages them independently. The choice can come down to how related the pieces of state are. If they tend to change together, like multiple values from one input object, having one state object might make sense. If they're separate or change independently, separate state variables might be simpler. Lifting state up. Often, in a React app, you have data that needs to be shared by multiple components. Perhaps two sibling components both need the same piece of information. The recommended solution is to lift the state up to the nearest common ancestor. For example, if component A and component B need access to some state X, then instead of each having their own copy of X, which could get out of sync, you put X in their parent's state and pass it down as props to both A and B, and perhaps pass down a function to update it as well if needed. This way, there is a single source of truth for that data. Lifting state ensures consistency. It is a fundamental pattern in React. Rather than try to synchronize state across components, which can become messy, centralize it at a higher level and feed it downward. A common scenario in our portfolio context could be, suppose you have a filter component and a gallery component. The filter, like a set of checkboxes for categories, and the gallery need to share the list of active filters. If they were separate, you'd have to somehow sync them. Instead, you'd put the filter state in their parent, say a portfolio page component, and pass down to filter component the current filters and a callback to change filters, and pass down to gallery either the filtered items or the filter criteria so it can display accordingly. That way, when filter updates the state via the parent callback, the parent has the new state and re-renders both filter, so it knows which filters are selected, and gallery, so it knows how to render. This unidirectional data flow with lifting state up is very much in line with React's philosophy. Derived state. Ideally, you keep state for things that are necessary and not easily computable from other things. If something can be derived from either props or other state, you often don't need to keep it separately because that can introduce bugs if you have to keep them in sync manually. For example, say you keep a list of items in state and also the count of those items in another state variable. You don't need to store the count separately because you can always compute items' length. Storing both invites a risk that someone might forget to update the count when items change. A classical example, in class components, some would do get derived state from props to derive state from props, but that can be tricky. In functional components, you typically derive on the fly, in the render, using variables or use memo if it's expensive. So a rule: if you can compute something from prop sock state during render, do that rather than duplicate it in state. State and performance. Updating state too frequently or having too many stateful components re-rendering can have performance implications, though React is quite optimized. A guiding principle: put state as low in the tree as possible while still covering all components that need it. If you put all state high up, like a giant global state, small changes cause a lot of components to re-render needlessly. By localizing state, you limit the surface of re-renders. For example, if each list item has its own internal hover state, keep it in the item component, not in a parent for all items, so only one item re-renders when it's hovered. Conversely, if state needs to be shared, you have no choice but to lift it to share. React DevTools and debugging. State. When developing, a tool like React Developer Tools, a browser extension, is invaluable because it lets you inspect the component tree and see props and state at any moment. This can help you verify if state is what you expect. Also, for debugging, it's often useful to add console.log in your functions to trace when state changes or when the component re-renders, to ensure things flow as you think. 30 asynchronous state updates. Pitfall: people new to React sometimes expect state updates to be synchronous. They might write something like set count, count plus 1, set count, count plus 1, and hope to increment twice, ending up 2 more than before. But because of how state updates are queued, this will likely result in count only going up by 1, because both calls captured the same count and queued setting it to count plus 1, if not using functional form. To properly do 2 increments, either call setCount with functional update twice, setCount, prev here's yos, prev plus 1, setCount, prev yersi, prev plus 1. This will indeed increment twice. Or call it once with plus 2 if that's simpler. Understanding this prevents bugs. Similarly, if you do set state in a class and then immediately try to use this state after, it won't show the update yet. Instead, use the callback or lifecycle, or in functions, rely on useEffect to react to changes if needed. State in class components, legacy context. For completeness, in case you encounter it, in class components, you define initial state. Usually in the constructor, this state, orsh, count 0, and update it with this, set state, count new value, arshas. One peculiarity: this .set state merges the new state with the old state for non-functional updates. In hooks, useState does not merge for you replace the state, which is why for objects you spread manually. Also, class setState is asynchronous too and can accept a function form this. SetState, PrevState, Arshai, similar to useState's functional updates. Complex state management, context, reducers, etc. As apps grow, sometimes state management can become complicated if a lot of components need to access or update it. One tool React provides is context, which allows you to create a context object and provide a value, state, at a high level. Then any nested component can access that value without threading it through props explicitly. Context is good for global-ish data like user info, theme, or in complex forms where many nested components need pieces of state. However, misuse of context can lead to many re-renders if not optimized. Some libraries use context cleverly with splitting values. We'll delve into context more later or in advanced sections, but know it exists as a way to effectively lift state even higher without prop drilling. Another pattern is using useReducer hook instead of multiple useState, which is akin to how Redux works but local. useReducer takes a reducer function and an initial state, and gives you state and a dispatch function. Instead of calling setX, you dispatch actions. This is useful if your state logic is complex, like many possible state changes, or state depends on previous state in multiple ways. It can help organize the logic. For example, a complex form where one field affects another could benefit from consolidating state updates in a reducer for clarity. 31. For global state across the app, libraries like Redux, MobEx, or newer ones like Recoil or ZooStand exist. But with hooks and context, often you can manage without pulling in external libraries for moderate complexity. Redux, for instance, centralizes all state in a single store. That's beyond our scope for now, but is something one might explore for very large applications. Example, to illustrate state. Let's consider building a simple image carousel in a fashion portfolio. You have a component image carousel that shows one image at a time out of a collection, with previous and next buttons. How would state come into play? The state likely includes an index for the current image, current index, and perhaps some autoplay toggle state or similar. The next button on click would call something like setCurrent, index, prevIndex, orash, prevIndex plus 1, modulo image's length to cycle to the next image, wrapping around. The component renders in with src equals images open bracket, current index close bracket. The text or any indication of position also uses current index. Initially, use state 0 to start at the first image. As the user clicks next or prev, the state updates, triggering re-renders showing new images. The component might also accept props like the array of images. That's props, not state. The state is just the index. If we wanted an auto slideshow, we could use a use effect to set up a timer that calls setCurrentIndex every few seconds, thus updating state regularly to move the carousel. Another example, a form with controlled inputs. In React, a controlled input is one where the input's value comes from state and changes to it call state updates. For instance, function, name form, const, name, setName, sound useState, return, setName, eTarget.value. Here, the input's value is bound to state name. When the user types, the onChange fires, and we update state with the new input value. That triggers a re-render, and the input's value is updated, or essentially remains in sync. This might seem roundabout, why not let the input manage itself? But controlling it via state allows you to also enforce constraints, do validation, or reset fields easily. It also allows React to be the single source of truth for the form data, which can then be submitted or manipulated as an object. This is a standard pattern in React for forms. Final thoughts. On state. State is what makes React apps truly dynamic. It's also the aspect that requires careful thought because improper state management can lead to bugs, like a piece of UI not updating when it should, or updating when it shouldn't. By keeping state minimal and focused, only what you need, and not duplicating derived values, and by following the rules of immutability and one-way flow, you can avoid many common pitfalls. Also, testing components with state typically involves either simulating user events, in which case, if your component re-renders correctly on state changes, those tests will pass, or calling the state updating functions directly and checking output, which, if pure enough, is straightforward. We've now covered how to hold and update state within React components. The next step is often to think about how to add more complex behavior and avoid repetition of stateful logic across components. This is where hooks beyond use state come in. And indeed, our next lecture will dive into hooks like useEffect, and 32 custom hooks that let you encapsulate side effects and reuse stateful logic. Hooks unlock many capabilities such as connecting to external systems or sharing common state logic in multiple places without repeating code. So, as we move forward, we'll build on this foundation of state management to handle things like data fetching, subscriptions, or other side effects via hooks. DNS management and deployment. We've built our React application, enriched it with state, data, and possibly server-rendered content. Now comes the final crucial step: getting it live on the internet under a domain name, so users, or in our case, maybe a hiring committee or audience, can access it easily. This last lecture, DNS Management and Deployment, will walk through how to take a React application, or any web application, and deploy it to a hosting environment, and how to configure a custom domain name via DNS to point to it. We'll break this into two parts. 1. Deployment, preparing and uploading our application to a server or service, such as a static hosting service for SPAs or a cloud platform for SSR apps. 2. DNS, Domain Name System. The system that maps human-friendly domain names, like yourname.com, to the IP addresses of the servers where our app lives. Building the React app for production. If you've been developing with a tool like Create React App, CRA, or Next.js, you have a build process that outputs production-ready files. For CRA, running npm run build produces a build/directory with static assets. Open parenthesis, HTML, CSS, JS images, close parenthesis. For Next.js, running build and npm run export, if doing static export, creates an npm run out top folder of static files. Or if doing SSR, you do npm run build and then run the node server. The build output is what you deploy. Production builds are optimized. Code is minified, whitespace removed, shortened variable names, split into chunks for efficiency, and often assets are fingerprinted with hashes in file names for cache busting. Deployment options. Static site. Hosting for SPAs or pre-rendered sites. If your app is all client-side or statically generated pages, you can host it on a static file server or CDN. Popular choices. GitHub pages. Good for CRA or Gatsby outputs. You host your branch, and GitHub serves it at build folder on a branch. JIH pages username.github.io or a custom domain. No server-side code allowed, just static. Netlify, a cloud platform with very easy static site deployment. You can drag and drop your build folder or link a Git repo, and it auto-builds on push. It provides a global CDN, continuous deployment, and supports client-side routing by redirect rules, etc. Vercel, from the creators of Next.js. Great for Next.js projects, auto-detects build, and does hybrid deploy of static and serverless for SSR. Also supports CRA and others. Also has CDN and automatic HTTPS. Surge.sh. Simple CLI tool to deploy static sites, very quick to publish. Amazon S3 plus CloudFront. You can upload your static files to an S3 bucket configured for static website hosting and put a CloudFront CDN in front for caching globally. Firebase hosting. Good for SPAs, provides CDN, easy CLI deploy. These services typically give you a random subdomain, like mysite.netlify.app, which you can use or map a custom domain. Node server hosting for SSR or APIs. If you need to run a Node.js server, like Next.js SSR or an API server, options. 114 platform that can host Node apps by just pushing code. It handles scaling but can be a bit slow on cold starts, and their free tier ended. Good for prototyping. Vercel. If using Next.js, Vercel is great. It will deploy SSR functions to their edge or serverless, and static parts to CDN with minimal config. Render.com, Railway.app. Newer Heroku-like services with free tiers to run Node servers. AWS Elastic Beanstalk/ECS/Lambda. More complex but scalable routes. For example, deploying a Next.js SSR to AWS Lambda via serverless framework, or containerizing your app and deploying on ECS. Likely overkill for a small project. DigitalOcean Droplet/VPS. You manually set up a Linux server, install Node, and run your app, perhaps with a process manager like PM2. Then use NGINX as a reverse proxy to serve it. This gives full control but requires managing the server, security, updates, etc. Hybrid hosting, e.g., static content on CDN, but some dynamic functions as serverless. Netlify and Versal both support serverless functions. Netlify functions, Versal serverless, triggered by certain routes or events. So you could host an API endpoint with them without a full server. For a portfolio site, likely we don't need SSR unless we want to experiment. A static approach is often sufficient. If using CRA, we build and deploy static. If using Next.js, could pre-render all pages, get static props, and export as static site, or use their SSR, but that would require hosting on Versal or Node server. If using Gatsby, it's static by nature, build to HTML files. Possibly use a CMS. If using headless CMS, Contentful, Prismic, etc., the site could be static but redeployed on content changes or use their APIs on client. Procedure for deploying a CRA app to Netlify, for example. 1. Install Netlify CLI or use their web UI. If using the web UI, you can connect your Git repository. Netlify will detect CRA and run npm run build and deploy the build folder automatically on each push to main. 2. Alternatively, run npm run build locally, then drag the build folder onto the Netlify web UI drop zone, or use Netlify deploy command specifying the build folder. 3. Netlify assigns a random name like affectionate albatani-12345.netlify.app. You can then set up a custom domain. We'll get to DNS soon. 4. Netlify automatically provides an SSL certificate via Let's Encrypt for your domain once configured. Continuous deployment, CD. Services like Netlify/Versal automate builds. Every time you push code, they rebuild and deploy. This is great for an active project. You don't manually FTP files. They also give deployment previews for pull requests. DNS, Domain Name System. This is how domain names resolve to IP addresses of servers. The Internet's phone book. Important terms. Domain registrar, company where you buy your domain, e.g. GoDaddy, Namecheap, Google Domains. They give you control panel to manage domain records or at least set name servers. Name servers. DNS servers responsible for your domain. When you buy a domain, by default it might use registrar's name servers. You can choose to use another DNS provider, like Cloudflare DNS or Netlify's DNS, etc., by setting name server records at the registrar. DNS records. Entries like A and AKNAME MX, TXT, etc. A record maps a name to an IPv4 address, e.g., yourdomain.com A123.4.5.6.7.89. Cyber A record maps to an IPv6 address. Name record maps a name to another name, canonical name, e.g. www.yourdomain.com, ename yourdomain.com, or to an external domain like yourapp.herokuapp.com. Name can't be set on the root domain, apex, in DNS spec. Some DNS providers have alias or ANAME pseudo records to allow that by flattening. MX record. Mail exchange 115 records for email routing. TXT record. Arbitrary text, often for verification or policies. SPF, DKIM for email. SRV, etc. Less common, for specifying service endpoints. Pointing a domain to your site. If using a static host like Netlify, they often manage DNS easily. Example, on Netlify, you add custom domain yourdomain.com. If you use Netlify's DNS, you point your domain's NS records to Netlify's, like DNS 1.01.ns1.net, etc. And Netlify then auto-configures A/C name for you. If not using their DNS, they instruct to add an A record to some IP and a C name for www to some Netlify alias. For instance, Netlify often uses one of their load balancer IPs for Apex A record. If using Versal, you add domain, Versal might ask you to either use their name servers or set up kname/A. Versal often has you add a kname for www to kname.versal-dns.com and an A record for route pointing to some short IP which routes through Versal. If hosting on GitHub pages. For user site, username.github.io. You set a CNAME of your domain to username.github.io and add a CNAME file in repo. For project sites, similar, plus possibly A records to GitHub's pages IPs. If on Heroku, you add domain in Heroku, they give a target like randomname.herokudens.com, which you set as CNAME for your domain or subdomain. They manage the actual IPS behind that. If on AWS S3 CloudFront, Amazon gives you a CloudFront distribution domain, like d12345.cloudfront.net. You set a CNAME from your domain to that and configure the distribution to accept your domain in its settings, plus attach an SSL cert via AWS Certificate Manager. If running your own server at, say, 123.4.567.899, you'd set an A record for your domain to that IP. Possibly a if you have IPv6. Then ensure the server, NGINX, or your Node app is listening for that domain, virtual host config. Also configure SSL. For your own server, you'd obtain a certificate. Let's Encrypt can automate via certbot and configure NGINX or the Node app to use it. Setting up email, briefly. If you want an email at your domain, like hello@yourdomain.com, you need to use an email provider, Google Workspace, Microsoft 365, Zoho, etc., or forwarding service. Then set MX records to point to that provider's mail servers and add verification TXT records they give. This is separate from hosting the site, but part of DNS management, often done together. DNS propagation. DNS changes take time to propagate across the internet. Each DNS record has a TTL time to live, indicating how long resolvers can cache it. Often default TTL is 1 hour or 4 hours. When you set up a domain's records, it might be reachable in minutes or could take hours, especially if you changed name servers, which can take up to 48 hours broadly, though usually quicker. When debugging DNS, use ENS lookup or dig commands or online tools to see if your records have updated in global DNS. HTTPS, SSL certificates. You want your site to be HTTPS. The browser will warn if not. Many hosts, Netlify, Versal, GitHub, pages with proxy, etc., provide free HTTPS via Let's Encrypt automatically once domain is connected. If self-hosting, you can manually use Let's Encrypt. Use certbot to get a cert for your domain. Requires proving domain ownership via a challenge, which can be auto-handled if you run it on the server that serves the domain. Certbot can auto-renew every 2 months. LE certs last 90 days. Alternatively, use a commercial certificate, but LE is free and widely trusted. Services like Cloudflare provide a flexible SSL where the user sees HTTPS to Cloudflare, but if your origin is HTTP, it's hidden. Better to have end-to-end encryption, though. Content Delivery Network, CDN. If using hosts like Netlify, your content is automatically served via a CDN. Their nodes globally cache your files. If self-hosting, consider putting Cloudflare in front, which can cache static assets and provide security with a free plan. Cloudflare DNS is also free and very fast. 116 deployment process summaries. CRA to GitHub. Pages. 1. Add homepage and package.json as https://yourdomain.dujum npm run build jum. 3. Use ghpages npm package or manually push the contents of build to ghpages branch. 4. On GitHub, ensure pages is set to serve from that branch. 5. Add a keyname file in public / with your domain if using custom domain, and configure that domain in repo settings, GitHub pages section. 6th set. DNS. Likely an A record to GitHub servers and a CNAME for www to your domain. There are specific IPs for GitHub pages. Next.js to Versal. 1. Versal, if you have their CLI from project root, or connect GitHub to Versal UI. 2. It auto-detects. Next builds and serves. 3. Add custom domain in Versal, Update DNS as directed. They provide either A plus CNAME or name servers. 4. Versal provisions SSL done. 3. Static to Netlify. 1. Connect repo or drag-drop build folder on Netlify site creation. 2. It's live on a Netlify subdomain. 3. Add custom domain, follow instructions to set either Netlify DNS, just change NS at registrar, or set AKE name. 4. Netlify handles SSL via Let's Encrypt automatically. 5. It even handles redirecting Apex to www or vice versa. You can configure domain aliases. Self-host node app. 1. Rent a VPSEG DigitalOcean droplet. 2.SSH in, install node, clone your repo, or upload code. 3. Build if needed, for next npm run build. 4. Start app, e.g. npm start if it runs an Express or Next server. Better use PM2 or similar to keep it running in background. Install nginx. Configure a server block for your domain. Server name your domain, proxy, pass to localhost 3000 where your node might run. 6. Open firewall for 80/443. 7. Use certbot to get SSL cert for your domain via nginx plugin. 8. After this, your domain resolves to server IP. You must have set an A record to Droplet's IP. nginx serves the initial request and static files, if any, proxies API requests, or SSR to node, as configured, and uses the cert to do HTTPS. 9. Maintain the server, apply security updates, etc. This is powerful but a lot for a small site. For a personal project, leveraging managed services like Netlify/Versal is usually easier and often free for low traffic. DNS management steps. After deploying site, say it's at example.netlify.app or on a particular IP, go to your domain registrar's DNS settings. If you use registrar's DNS, add records, typically an A record for root and CNAME for at www. If using a platform that gave you a target domain, like project.netlify.app, you cannot CNAME the root. Some registrars have alias or anime to allow mapping root to a domain. Netlify overcame this by providing an A record. They have a common Anycast IP, e.g. for Netlify, yourdomain.com, a 75.2.60.5, one of Netlify's IP, and www.yourdomain.com. CNAME Optimistic Albatani -12345.netlify.app. Netlify's docs list exactly what to do. After that, Netlify detects the domain pointing and issues a cert. Or if you switch to another DNS like Cloudflare. On Cloudflare, you'd add your domain. Cloudflare scans existing records. Then you change NS at registrar to Cloudflare's. Now you manage records on Cloudflare's panel. Cloudflare also can proxy the traffic, Orange Cloud, providing CDN and security. If using Netlify with Cloudflare DNS, it's a bit double CDN. Often you either use Cloudflare for everything, point domain to your server and use their caching, or not at all. But Cloudflare can simply do DNS only, gray cloud, so it doesn't conflict with Netlify's. CDN. Always verify by using DIG or an online DNS checker for the new domain to see if it resolves to the expected host IP or alias. TTL management. If you're about to migrate a site, you might lower TTL of records a day before, so that when you switch IPs or providers, caches update faster. But for a new site, it's fine to leave default TTLs. Once live, test the site in an incognito browser or on a mobile network to ensure it's accessible and the certificate is valid. No warnings. Possibly set up a monitoring. There are free monitors that hit your site every few minutes and alert if down, e.g., Uptime Robot or Better Uptime. Probably overkill for a portfolio unless mission critical, but good practice. 117. Wrap up. Deployment and DNS are the bridge between your development environment and real users. It's an area often overlooked in coding courses, but it's where many practical headaches can occur. Knowing how to configure a domain, how to troubleshoot if site not found, check DNS, check host logs, etc., is extremely valuable. And it's a satisfying phase. You get to see your creation accessible to anyone on the web. For your own fashion portfolio, having it on a custom domain like yourname.com rather than a generic hirakuapp.com or netlify.app domain can make a more professional impression. This lecture should empower you to do that configuration confidently. Congratulations on making it through Week 1's comprehensive journey from coding in React all the way to deploying a live site.